Okay, so YJ, thanks again. Thank you so much for being here and for assisting us. Yeah, we are very excited to hear about your project introduction and case study. Yeah, please, it's your turn now. Thanks so much.
Okay, thank you. Can we start?
Yes.
Hello, ladies and gentlemen. I'm YJ again from BCT. It's Busan Container Terminal, currently under construction. As you see it in the background, the crane is delivering now. So for these sessions, I like to talking about our terminal introductions and then case study for the emulation project. So I'm take care of the IT and equipment side. So normally some guys talking about the why too many walks. But in the recently the equipment is going to the automation. So some party of the equipment side doesn't know about the automation. So that's why I'm just take care of both sides. So let's go to the overviews. This is an overview of the Busan New Port area. So there's a existing 5 container terminal already operations. So here we are BCT is the under construction. Is we have 3 berths with queue length is 1,050 meters, and then water depth is 17 and 18. So we plan to go live next April with 1 berth. And then 2 months later, we'll go for the 3 berths with 16 blocks. So in the beginning, this is a previous photo of our terminal area. So it's backward, there's some sections for the hinterland, for the like warehousing and factory like that. And then our neighborhood is a BCT. I also involved in the BCT project for the automations. So all layout is similar. So currently, the actually this photo is maybe a few weeks ago. We have a lot of more cranes now we are testing. So up to now, I expecting automation side is maybe December. I will trying to live equipment test. So we are very busy. So and then in the future, we will go like this, and then the 22 automated block, and then each block have 10 nodes, 45 bays. So the reason I like down this 10 node and 45 bay is when I started the previous project, it's very difficult to find out this kind of some simple information to learn why they are choosing this kind of length or how many bays. So we already have like some tools like Google Earth, everybody can see. So that's why I'm just write down all the simple information for your reference. So for the automated block, we put the dry and leaper and hazardous. And then there's also empty. And then the total, we have 1282 TGS. So in the layout side, this is a vertical layout. So in the QC side, we set the QCTP, stand for Quick Crane Transfer Point. This is not physical. This is a vertical according to the crane side. So I'm trying to trigger and then find out how temporary container located in this area. And then there is another one, water side transfer area. We have a tow lane for all 16 TUs buffer. So, and then land side, we have 6 lanes for the external truck and internal trucks for the gate delivery and receival. And then this also can be used internal move. So, and then the final one is there is some additional empty stack area. So this slide just trying to show the buffer area is very important in the semi-automated or automated terminal. And then this is just the operation concept of our terminal. So basically, as you see in the top, there is a terminal operating system, TOS. And then equipment control system working together to exchange their work order or some work result. In the ARMG side, normally you can say ASC is automatic stacking crane, is a fully automatic RMGs. There's no man's inside crane working. There's only a remote operator for the exceptional case. And also in the STS, we introduced remote STS for everybody key crane driver working in the office. So in the key side is remote, but only in the apron side is manual. So human take control of the straddle carrier. And then each block have two ASCs for the loading and discharging and delivery and receiver containers. So on the gate automation is very popular in this area. So this is all our operation concepts. And this is the equipment side. So for STS, we are 24 loads. Our reach is 70 meters. Raise span is 35 meters. Then lifting height is 53, is highest in the Busan Newport. And then to compensate for the automation, we upgrade the trolley speed, 240 meter per minute. This means to compensate for the slow of the automations. So in the normal, our study, I think it's a very similar performance we can do for the auto terminal. And then the other crane side is ASC is 2 cranes per block in the lineman types is 10 nodes and then 5 high they can handle. And then we introduce a straddle carrier. For the main reason for the straddle carrier is independent operation. So in this case, independent operation means the Q crane can walk by himself and then the discharging and loading work if there is a container. And then straddle carrier just also same lifting and set down capacity so they can handle by themselves. And then ASC also doing by himself. So that means if we have enough purpose, we can reduce the number of equipment. That's the concept of the independent operations. So the other one, terminal truck, is just, as you know, all of the similar, same concepts. So the number of the equipment is below table. Is we totally 11 key crane we will introduce. Then for the next slide. So for the schedule, we start 2016 for the constructions. And then the first batch of STS and the ARMG arrived last August. And then we are preparing for the live equipment test. And then the next April, we'll go live with one burst. So this is a simple project introduction. And then now I'm going to the case study. So I'm working with the CHESSCON virtual terminal tools for our terminal. So maybe 1 or 2 years ago already. So the reason I selected this emulation approach is last project in the previous I had a lot of difficulties. At that time, I also introduced the emulation, but the timing, scheduling is very later. Is a final stage I introduced this emulation. So I lost a lot of chance to testing for the DOS. So that's why I start earlier for this virtual terminal. So in the structure-wise, so as you see that there is no ECS. Is the only connection with the terminal operating system and then virtual terminal emulation side. So all the equipment size automatic. That means if you learn emulation, then the tools can interact. So user just need to learn and then prepare some data like loading and discharging data. But this is one instance. I will try to explain more later on about the instance. So the next one is we introduced the Novice Tools. This is not very famous, but not good reputation to the end user. But anyway, we are starting with the Novice M4, and then all the interface with CHESSCON is, for example, like ECM4 is talking with Strayer carrier. The Crane API is a remote SDS. AYC manager is ASC, and then the Gate API, and then Universal API is all the APIs working with Novice and CHESSCON. So we are first terminals to using Oracle database for the ASC interface. So up to now, we are very easy to learn, to test. So for myself, sometimes every morning, I just start learning emulation. So for specific reason, like for example, what if I received 100 trucks at a time, like that. So, but the one more important things I learned using this CHESSCON system is we need several instances with matching with the CHESSCON plus TOS. So I segregate 3, but I'm only have 2 instances now, and then I plan to use the other one for the last one. So first one, basic operation is I just focusing on the basic operation, and then I use this one as a configuration servers. So means in TOS wise, there's a lot of configuration, so I want to keep it. And then I test it, and then I for the basic operation. This can be useful for the hardware upgrade, or in case of M4 side upgrade. So I already experienced the 3 times upgrade from the Novice side. So that's why for that purpose, I use this basic operation instance. The second one is ASC optimizations. For this instance is for the yard crane optimization. I trying to change some parameters or some configuration. So in that case, I trying to learn this ASC optimization. That means if I found some fine-tuning result, and then I will apply to the basic operation again. The third one, lab test, is just I'm trying to do that, but I not execute yet. I'm just very focusing on the now ABB and the Novice side. But in this case, I'm just trying to turn up some part of the CHESSCON, and then instead of CHESSCON, I just put the ABB emulations. Means this is a manufacturer providing emulation software. So they only provide yard crane or SDS crane side. So that's why I'm just trying to interface to learn together. So for next one, I'm just trying to test again. This is similar with the ASC optimization, but maybe we are greenfield. In the beginning, I think we can use this parameter, but in the some yard occupancy is growing up, we need to test again. That's why I'm just to use this another instance for the prime node and then export hacking like that. And then the secondly is a basic operation again is for the version upgrade from the Novice side, hardware the upgrade. If we want to add some more hardware, I will use this basic operation first. And then the final one is equipment efficiency. I'm just trying to talk with CHESSCON already. This is for my personal idea in terms of terminal operations. What is the best efficient operation? So that means every operators want to learn fast. Every operators know the speed is the highest. But in terms of overall terminal cost, I think if we reduce the some speed, then we can also reduce the prevented maintenance, or we can reduce the downtime. So that means I trying to need to show my result with my shareholder or my operation guys. This is my target for the next. Okay. Then this is the emulation noise. Every time I try to learn, maybe this is you all of guys are familiar with this screen. So every time I see the how it's going. So still I try to learn for the emulation side. Okay. The next one, lesson ones from this project is basically introducing emulation is also one of a project I need to focusing on. It's not just it works. It's not. It need to more time, and then it need also resource, and then you also need to hardware if you want more instance. So I bought a lot of additional equipment for this testing, and then the proper scheduling. So this is very important, I think, if you plan to introduce some emulation side, is TOS is basically should be learned, and then you talk with the emulation side. But this scheduling is very important. If you have a starting at the once, that means you will start with the TOS. Then the emulation side have to wait. So that's why the proper scheduling is very important. And then the next one is I'm just sometimes in the beginning I'm confusing some errors and find some fault, but I don't know who did some errors. The main cause is very confusing sometimes. So that's why I'm just talking with the CHESSCON support and then Novice guys together. And then I just trying to focusing on the some benefit. So normally we're talking about through the emulation, you can test, training, and tuning. So as I explained, all the tests is we are already done. And then the tuning is one of our main goal for this emulation. And then training is just for the planners, I think. So this is based on these three benefits. I just thinking about the benefit of this CHESSCON is easy to learn. Is it means learning is very easy. I have some another emulation tools. It's very difficult to learn. It's a lot of more hardware is required. And then I got some good support from the CHESSCON side. This is my just feeling. And then the one additional good thing is you can present to your shareholders for more realistic how it operates. Is someone not familiar with the container terminal industry, like bankers, like some construction companies. So this is all I prepared. So this I'm done.
Excellent. Dear YJ, thank you so much. Very, very exciting. And of course, a little bit of advertising. Of course, we love to hear that our tools are very useful for your business case, and that at least the simulation tool is easy to learn. Of course, the emulation is always a bit tricky, but I think it's also a very powerful tool. So thank you so much. Thanks a lot.